Waves homework booklet question 17. Figure below shows a glass prism. Light is directed into the prism at 56 degrees. So that is meaning at 56 degrees to the normal, which they've made unambiguous by showing it on the diagram. And the path of the ray of light is shown as it enters the prism. Calculate the refractive index. As usual, if we can get away with doing this, let's just use n1 sine theta 1 equals n2 sine theta 2. Rearrange that, that'll give me n2 is sine theta 1 over sine theta 2. n1, we're in air, so that's where this 1 comes from. So that's n1 over times sine theta 1 over sine theta 2, and it comes out to that value shown. Calculate the critical angle or for the glass air boundary. Now again, you can go straightforwardly with n1 sine theta 1 is n2 sine theta 2. Theta 1 becomes the critical angle when theta 2 becomes 90 degrees. That means sine of theta 2 itself becomes 1, and we get sine theta c equals n2, taking that under, divided by n1, and that essentially disappears because it's 1. Or you can just start with the equation. Sine theta c is n2 upon n1. You do have to get that the right way up. It's the material it's heading towards divided by the material it's currently in. n2 divided by n1, 1 for air, divided by my answer from the previous question, gets me that. And then if you've written what sine theta c is, you're then okay to write what theta c is, simply using the inverse sine button. If you use 1.7 from there, you actually get 36 degrees, and that was accepted as well. And then on the figure above, continue the path of the ray of light until it comes out of the prism. So we know that it does that much. I'm going to draw the normal on, that's the first thing I did, and then I had a thought about what is my angle of incidence at this boundary. Well, I've got that angle is 30 degrees, and the normal is parallel to that edge because that's 90 degrees. So that means that angle there is also 30 degrees, which makes that 160. First question I've got to ask myself, if I'm working out where things are going, is that angle bigger or smaller than the critical angle? The critical angle I worked out down here is 37 degrees, so it is bigger, so I get total internal reflection. So I measure that 60 degrees, I measure that 60 degrees, draw my line on, and it arrives at that point there. I've now got a new boundary, and I'm going to put a new normal on, and I've got to work out what angle that's hitting there. Yuck. Well, it's not too bad actually. I've got 30 degrees here. If that's 60 degrees, that one's 30 degrees. So I've got an isosceles triangle here with two 30 degrees in. And that angle therefore must be 180, take away those two lots of 30 degrees, which is 120 degrees. Because that's my normal, that's 90 degrees, which leaves that as being just 30 degrees. 30 degrees is less than my critical angle. Now I've got to imagine here I'm coming down along here, and I would do it with my finger and my thumb, and if I had my thumb coming down on that side, my finger coming down on that side, it's my thumb here which is going to speed up first, and therefore the ray bends from there to there, it bends away. So the thumb coming along there speeds up before the finger coming along there, and hence there's time where that's wheeling around there. We change that direction, we end up further away from the normal. Remember, at each boundary you've got to do the geometry and ask yourself, am I at above or below the critical angle? That's key to working out these where are the rays going to go question. So that's the Waves homework booklet question 17.